Good morning, everyone, at Room C1 West St. Paul. Mr. P back here today. We're going to be talking about our next topic for science. Sorry, it's been a long day of video making. I'm kind of forgetting where we're at here. The first thing we looked at in volcanoes and earthquakes was volcano myths. We looked at the fact that most people believe gods were in charge of this if we go back long enough, and that there were many societies like the Hawaiians who had the god Pele, who was believed her hair was made of lava and she caused the volcanoes to erupt. We have Glooskap, also known as Wissahickajak, from the indigenous people of Canada, who believe that there was this god who created the Sugarloaf Mountains, or who created the other types of earth-changing events that we had. We have the Greeks, especially Anaxagoras, who believed great winds inside the earth were causing these earthquakes to happen. We have Romans like Ovid, who said that the earth was getting too close to the sun and trembling from the great heat. And we have Rene Descartes in the Middle Ages talking about a glowing core. We even have the island of Atlantis as a story created by the explosion of a volcano. We looked at the three types of volcanoes: the ash and cinder cones, which are the smallest, which cause quite a bit of damage. They're made from layers of ash and cinder, and a great example, if you watch the videos, was Paracutin in Mexico. We have shield volcanoes. These are the largest volcanoes. They're whole islands. They don't have a bowl-shaped crater like ash and cinder cones. They have fissures that erupt all over the different parts of the volcano. They erupt slow moving lava, and we're going to talk about that a little more today. Instead of explosive, they have slow moving eruptions that happen, and they're made from layers of cool lava. A great example is Mauna Loa in Hawaii. And lastly, we have stratocones, also sometimes called composite volcanoes. These are the tallest, not the largest, but the tallest volcanoes. They can erupt violently when they get plugged. They erupt ash, cinder, and lava. Mount St. Helens, if you watch the videos, was the example that we gave for that type of volcano. Today we're going to talk about eruptions and hazards. Now, most people obviously know some of the hazards of volcanoes, like the lava and the heat, but there are a lot of things that happen when volcanoes erupt, and most of the damage isn't actually caused by the lava. So follow along with your note-taking guide today, and let's do this together. First of all, the volcano is made of essentially 4 different parts, and it's very, very simple. The opening at the top of a volcano is called a vent. Now, sometimes shield volcanoes will have fissures or cracks that open up, and this is also sort of a vent because that's where the lava will escape. Now, when the lava is inside the earth, it's called magma. It's only lava once it exits the actual volcano. Now, the cone is the large cone-shaped structure that makes up the vast majority of what you see when you look at a volcano. Conduits are these these long paths that go right from the core all the way up to the vent. So this is how the magma travels to the surface. And lastly, at the very bottom, deep inside the earth, below the crust, we have the magma chamber, where all of the magma is stored, and it sort of slowly seeps its way up to the top of the volcano right there. I wonder if you can see my pointer. Sort of. Now, how and why do volcanoes erupt? Now, large amounts of gas and sticky magma will form an explosive eruption. So there are 2 types of eruptions. The first one is called an explosive. Now, think about like shaking a drink and then just popping the cap, it'll all sort of explode out of the top. Now, that's what we call an explosive eruption. And you're going to see that in ash and cinder cones and stratocones. There's a different type when there's small amounts of gas or magma that comes out, and we call this an effusive eruption. This is where it just trickles out very slowly. We call this lava flow. Now, this is what we have with shield volcanoes. So there's 2 types. There's explosive and there is effusive eruptions. Now, we're going to look at both of those, but let's first talk about the most common type, the one that most of you guys are familiar with when you think about volcanoes, and that's an explosive eruption. So in Alaska, Mount Redoubt is right there on the side. Alaska has a ton of volcanoes, and this is one of the pictures taken from one of their more recent explosions. Now, explosive volcanoes can be catastrophic. What that means is they can cause a massive amount of damage and death, depending on where they are. And we're going to look at a couple today that are centered around major cities with millions of people. Now, they erupt anywhere from 10 to thousands kilometers of magma. So the magma can actually travel anywhere from 10 to 1,000 kilometers away from the volcano, which is a lot. That is extremely far. And they can send ash clouds up to 25 kilometers into the stratosphere. So this is massive. Like, these things have incredible power. They have severe environmental and climatic effects. So if you have enough of these volcanoes erupting at once, it can cause massive problems with the world climate. And some of the great historic events that we're going to be looking at in our next unit, or sorry, I should say later on after earthquakes, have to do with massive amounts of volcanoes erupting at the same time. Now, there's three things that happen when a large volcano erupts. The first one is called pyroclastic flow. The second is called pyroclastic surge, and the last one is called pyroclastic fall, sometimes known as ash fall. Now, if you look at these pictures on the right, and you can see them better if you pull up your own PowerPoint, this is the city of Montserrat, and it is completely buried by what we call pyroclastic flow that will literally cover entire cities in ash, dust, and magma, or lava, I should say. So here's a really good idea of what happens. So look at your volcano here on the right. So the volcano is erupting. It's an explosive eruption. So this is most likely a ash and cinder cone or a stratocone. Now, a few things are happening during the eruption. The first thing you're going to see is right here, pyroclastic flow. That's all of the material, heavy material, rocks, particles, ash, all of these things are just flowing down and covering absolutely everything. Mount St. Helens, if you watch the Raging Planet video, it shows the trees just getting ripped right in half. It shows landslides just destroying everything around it. And that's the flow, okay? Up in the air, we have known as the pyroclastic surge. Now, that is the lighter particles, the gas, the very light particles that get picked up by the wind. And this is an eruption cloud that just races forward. And as it goes forward, ash fall, or the cinder falls and burns buildings, forests, everything that comes underneath it. So you have the flow, that's the light particles, the gas that's going up into the air. You have the surge, I should say. You have the flow that's staying really low to the ground. It's heavier particles. And then you have ash fall, which is coming down. All of these three things happen around the same time, and they can be absolutely devastating. Now, pyroclastic flow are hot and turbulent, fast-moving, high particle concentrations. So what does that mean? Okay, so that means a few things. These are fast-moving. They're high particle. They're made of rock, ash, and gas. They can travel about 100 kilometers away from the volcano. So 100 kilometers. Now, if you want to put that into just a tiny little bit of perspective here, we're at West St. Paul's School. Now, I think most of you probably know where Selkirk is. It's about 20 kilometers from here, okay? So about 20 kilometers from here. Now, if you want to go a little bit further than Selkirk, you go to Gimli. Now, when you get to Gimli, you're looking at roughly just under 100 kilometers. So you want to go a little bit further. I'm not sure if you guys really know the geography around here. But think of it this way. It's if a volcano erupted right around here in West St. Paul, the flow, so the heavy part that travels down the volcano and stays close to the ground and covers everything, it's going to go about an hour away from here to around Gimli in all directions, usually. It tends to go with the wind, but they can go in all directions. They will destroy everything in their path, buildings, fields, forests, and because it's a high concentration of particles, they stay low to the ground. So they're going to follow valleys and stay low. This is what's going to rip the houses apart. This is what's going to bury anything. It's going to destroy forests. It's going to do all of those horrible things. Now, surge is a bit different. These are lighter particles. They're low particle concentration. They come out of the volcano, but they get picked up with the wind and they stay higher to the sky. It's mostly gas, but there are particles in it. Now, these can travel, because they're lighter, they can travel as fast as 300 kilometers per hour. They go over top of things. So these aren't the things that are going to stay low to the ground. So here is a beautiful picture, by the way. And I mean, the people who took this picture would have had to have got out of there ASAP. This is a massive amount of pyroclastic flow that's coming right at them. It looks like a tidal wave. Now, in there is burning hot, turbulent gases. So whoever is taking this picture is going to have to get out of there rapid fire, and they may not even be able to get out of there fast enough. They are extremely dangerous. Now, effusive eruptions, these are different than explosive ones. These are slow-moving lava. Okay, look at the picture on the left of Hawaii. This is slow-moving lava. And because it's slower moving, it's generally easier to get away from, but it's going to easily knock houses down, it's going to burn fields, and it's going to trap things. Look at the picture on the right. You can see there that you have cars buried inside cooled lava. So remember, the two things we're looking at today. We have explosive eruptions that let off pyroclastic flow, which goes down the volcano, pyroclastic surge that goes up in the air, and ash fall. And then we have effusive or slow-moving eruptions. We're going to look now at some really interesting examples of volcanoes. This is kind of an interesting part here. So the first one here is some volcanic fatalities. Now, in terms of fatalities, or another word for death, is earthquakes are way higher. There's earthquakes that have killed hundreds of thousands of people. Volcanoes are not as much, normally because we know where they are. And generally speaking, we can kind of predict when a lot of them are going to erupt. If you look at a lot of these volcanoes, the four volcanoes with the highest deaths, they're all quite old. None of these are even in the 20th century, except for Martinique, which is barely there. The most deadly volcanic fatality that we've ever witnessed was in Tambora, Indonesia, that had 92,000 fatalities. That's a very large number of people. But look at the date, 1815. Okay, 36,000 people were killed in Krakatau, Indonesia in 1883. As you can tell already, Indonesia is a hotbed for volcanoes. Mount Pili in Martinique, 29,000 people passed away in 1902. And in 1792, Mount Unsen in Japan, 15,000 people. Of course, nowadays, we don't see nearly as many deaths. If you look at the picture on the right, some people don't notice it, but that's a man laying down beside a massive chunk that was blown off a volcano. Now, some of the hazards that come with volcanoes, we already talked about pyroclastic flow, okay? That's just the rock and everything that's just covering buildings and destroying everything. There's also what are known as mud flows, and this is lahars, or another name for them more in Asia. But we see mud that flows down from these volcanoes that covers towns and can be quite devastating as well. Pyroclastic fall is that ash that burns and falls from the sky. Lava flow, of course, with an effusive eruption, you have slow-moving lava that will come out. Two things we didn't talk about, noxious gases. So being too close to a volcano, you're going to get a lot of noxious gases from sulfur and other things, which can be extremely harmful to humans and other animals. And of course, with volcanoes often come earthquakes. They're very much tied together. Now, pyroclastic flow, one of the greatest examples of this is the Mount Vesuvius, which destroyed the city of Pompeii in AD 79. So we're going to talk about that there. So beautiful city of Pompeii, Roman city. You can watch tons of videos. I'm going to link one here for you to see. I definitely suggest watching it. Vesuvius erupted quite unexpectedly and absolutely destroyed the city of Pompeii. Now, what happened is on August the 24th of 79 AD, Mount Vesuvius literally blew its top, very much like Mount St. Helens did if you watch the Raging Planet video, erupting tons of molten ash, pumice, and sulfuric gases miles into the atmosphere. Now, the pyroclastic flow came down from the volcano and covered the city of Pompeii and all of its surrounding areas. Now, when the city was eventually excavated in the 16th century, people started to find, the archaeologists were actually finding dogs, animals, and people whose bodies were almost completely covered and intact. And what I mean by intact is they were almost casted, if you could think of it that way, in this molten lava. Of course, their insides and everything are long gone, but if you look at the picture of the left, it's a dog, and a picture of the right, these are people who are sort of huddled inside houses and places trying to not, trying whatever they could do to get away from the volcano. It was obviously not going to do anything, but the cities were suffocated and the inhabitants were buried inside the buildings. Now, the cities remained buried and undiscovered for almost 1,700 years until the excavation began in 1748. Now, these excavations continue today, so we're still finding parts of the city that are being... This was a big city, by the way, but we're still finding parts of the city that we never knew were there. Now, here's the crazy thing, and I want you to look at this map as best as you can. Now, there's Vesuvius right there in the middle of the map, okay? So that volcano is still there today. It blew its top, but it's still there. Now, it is a hazardous volcano. It hasn't erupted in an incredibly long time, since Pompeii, but that doesn't mean it'll never erupt again. This is not a dormant volcano. It still could be active. Now, today, The city of Naples, which is right here, it's a very populated city in Italy, is right there. And there are 1.5 million people who live in the city of Naples alone. So all around here, you have 1.5 million people living around this volcano. Now, it's only 30 kilometers from Vesuvius. So here's Vesuvius. Here's the major center of Naples. That's only 30 kilometers. But as we talked about, pyroclastic flow can travel up to 100 kilometers. So if Vesuvius ever erupts again, this is going to be horrible for the people of Naples. Now, will they be able to get out in time? Probably, but their homes and everything around there will be destroyed for sure. Here's another great, interesting volcano. This is Mount Pelee in Martinique in 1902. So we do have photographs in 1902. We don't have photographs of Pompeii, unfortunately, but there was an eruption here that produced a pyroclastic flow that destroyed the city of St. Pierre. So if you look at the picture on the left, okay, picture on the left, that is St. Pierre before, and this is after the volcano erupts and all of the pyroclastic flow destroys everything. 29,000 people died and only 2 survived. So this is a really, really interesting tale of how these 2 people survived. They became quite famous after and actually started traveling with a circus called Barnum and Bailey as the greatest, as sort of the indestructible men they were called. Okay, these 2 survivors. So what happens? Oh, I thought I had it on here, but I know the story, so I'll tell you. So the night before the volcano erupts, there were 2 men who went into a bar in St. Pierre and got in a little bit of trouble. Maybe they had a bit too much to drink and they got into an argument or a fight with somebody, and they were taken away to a prison for the night. So that they can be put away. Now, this prison was underground and it was completely sealed in. Now, what happens is they get put into this prison and boarded up. The volcano erupts, it covers everything, destroys everything. And a few days later, some rescuers who are looking for bodies hear their yells and screams from inside and actually get them out. So these are the only 2 survivors that we know about, at least from this massive volcano. Now, there is a number of ways that volcanoes directly cause damage. And the first is just impact. So these flows will just ram right into things. So they'll just destroy buildings, they'll knock over trees, they'll just destroy anything from direct impact. They bury things. So sometimes they'll bury a house and anyone inside could possibly suffocate if they're not lucky enough to have some air to get out. Burns, of course, this pyroclastic flow is burning hot, so it's going to shred trees and burn animals and burn people. There's mudslides, so they may get caught in the path of these, and of course they're fast flowing, so you get caught up in them. And of course the ash fall, it will burn roofs, it'll bring down power lines, it'll kill plants, it contaminates the water, and it's a respiratory hazard, so people who have breathing issues, asthma, bronchitis, emphysema will have a hard time breathing in these things because of all the dust. The lava flow, of course. Lava flow was a great example in the volcano of Hemay, Iceland in 1973. So there was a large eruption in Iceland. Now, I'm not even going to pronounce the name of that town, Vestmannaeyjar. Not good with my Icelandic. But here's some pictures of that eruption. Quite beautiful pictures of it, even though it was a horrible thing. And the lava flow caught the inhabitants by surprise. So the people weren't expecting the lava to go this far. So before the eruption was over, approximately 1/3 of the town had been destroyed. However, the potential damage was reduced by spraying seawater onto the advancing lava flows, which caused it to slow down and it caused it to cool faster. Now, we're not going to go into the rest of this because that's as far as we're going to go today. We can talk a lot more about other things, but that's kind of getting into earthquakes, and we're going to touch on that in the future. So thanks for following along today, guys. Make sure you watch the attached videos. Make sure you do the note-taking guide and follow along. We're almost done with volcanoes. We have one last thing to talk about, and then we're going to be moving on to earthquakes. Hopefully we're back at school because I'd love to do earthquakes at school. We have some fun labs and some things we can build, but we'll have to wait and see how this thing plays out. So nice talking to you again. Have a great day. See you later.